Assalamualaikum, my name is Nurul Safiah.
Good morning, everyone. My name is ABISHEKRAJ ELANGOVAN.
Okay, hi, my name is IRSYADUDDin bin NAZRI.
This is Mas NURANNISSA binti ISHAK.
Hi, my name is Muhammad NURHALIM bin HAMZAH.
My name is Muhammad bin SALLEH.
So our group will present on ROS2 for autonomous mobile robots, AMRs, in warehouses. Over the last decade, AMRs are being used in many warehouses or distribution centers. They improve workers' productivity and speeds up workflows in order fulfillment, which leads to higher client satisfaction. AMR are used for order picking, replenishment, and transporting goods. Because they are highly flexible, AMRs are perfectly suited for dynamic environments where requests are constantly changing. But first, let's look at how their brains operate. What is ROS2? It stands for Robot Operating System 2, which acts as the software brain of an AMR, handling critical tasks like mapping, path planning, and obstacle avoidance to turn it into an intelligent self-driving machine. Instead of human driving the robot or the robot blindly following the magnetic tape lines on the floor, ROS2 enables the AMR to navigate a crowded warehouse and make its own decision and safely deliver the cargo.
I'm going to talk about engineering technology challenges of using ROS2 for autonomous mobile robots, also known as AMRs in warehouse systems. One major challenge is job displacement versus job transformation. Many workers worry that robots will replace human jobs. However, in Industry 4.0, jobs are actually changing rather than disappearing. Workers now need new technical skills such as robot monitoring, ROS2 programming, and system maintenance. This matches the issue shown in the slide where Malaysia faces shortages in Industry 4.0 talent and skill enhancement. The second challenge is worker safety in human-robot collaboration. AMRs work together with humans in warehouses, so safety is very important. Engineers must design reliable sensors, obstacle detection, and emergency stop systems to prevent accidents. ROS2 helps by improving communication between robots and sensors in real time. Another challenge is reliability in critical logistics system. Warehouses depend on robots for fast delivery and inventory movement. If the ROS2 network fails or communication becomes unstable, operations may stop completely. Therefore, engineers must ensure stable networking, cybersecurity protocols, and backup systems for continuous operation. Thank you.
Today, I want to present about positive impacts of ROS, which is Robot Operating System for autonomous mobile robot in warehouse. So by bringing ROS2 into a warehouse, it changes the whole game for the better in three simple ways. First, it gives workers a promotion. Instead of doing heavy lifting and walking miles all day, the robots do the groundwork. So this lets human workers step into a cooler, higher paying tech job, like managing the robot fleet or fixing the machines. Then the second one, it keeps everyone completely safe. An old school robot had to be locked behind a metal cage, so they wouldn't hit anyone. But ROS is different. It is a super smart robot. They use advanced sensor to see people, predict, and instantly stay around or stop safely, so it wouldn't hit anyone. And finally, it means the works never stop. So the software is built so that the robot don't rely on one single computer to think. If one robot gets stuck or lose connection, it doesn't freeze the whole warehouse. The rest of the fleet just keep moving, keeping operation running smoothly 24 hours. In short, Robot Operating System 2 creates a workplace that is smarter for business, safer for humans, and always on the move. So that is all for positive impacts of ROS in warehouse. So I hope you guys understand the presentation, and we will move to the second part, which is the negative impacts of ROS.
Although ROS2 autonomous mobile robots improve efficiency and productivity in warehouses, there are also several negative impacts that should be considered. First is job displacement. Many repetitive manual tasks are now being replaced by autonomous robots. As a result, low-skilled workers may lose their jobs, especially those who are not prepared for Industry 1.0 technologies such as robotic and automation. Besides that, safety is another major concern when humans and robots work in the same environment. If the RS2 system, sensor or communication network fail, robot may collide with workers or create dangerous situations inside the warehouse. In addition, ROS2-based warehouse systems depend heavily on stable networks and real-time communication. Any system failure or network disruption can interrupt warehouse operation, delay deliveries, and cause financial losses to the company. Therefore, although AMR technology offers many advantages, its negative impacts on employment, worker safety, and system reliability must also be carefully addressed.
Hello everyone, my segment focused on a crucial balance in ROS warehouse automation, aligning cost effectiveness with professional ethics. In engineering, it's tempting to view automation purely throughout the lens of short-term ROI, reducing labor costs and maximizing speed. However, our professional norms dictate that we must consider the broader social impact. Okay, first, instead of simply replacing workers to save a quick dollar, an ethical approach is to prioritize jobs transformation. By upskilling warehouse staff to operate and maintain these ROS fleets, we protect livelihoods while retaining valuable institutional knowledge. Next, the second one is cost effectiveness. which is cost effectiveness must never compromise safety. Cutting corners on LiDARs or safety sensors violates our standards, while ethical implementations like staff upskilling and uncompromised safety hardware carry high upfront costs. They are the true foundation of long-term sustainable ROI. They prevent massive financial loss from expensive staff turnover, regulatory fines, and operational downtime. Ultimately, ethical automation isn't measured by how many people we remove from the warehouse, but by how many people we empower. Thank you.
Next, I will explain the long-term impact of professional ethnic and loom in a robot warehouse system using ROS2. First, let's talk about safety and risk management. In robotic warehouse operation, safety is not only about preventing accidents, but also about creating a safer and smart working environment for the future. By following strong safety standards, company can reduce operation risk, protect expensive equipment from damage, and minimize health hazard for workers. In the long term, workers are no longer required to consistent work in dangerous warehouse zone because robots can handle high-risk tasks. This allows human workers to move into more skilled supervisory and monitoring role which modernizes the overall workplace safety culture. Next is accountability and system transparency. Professional ethnic require RS2 system to operate transparently so that every robotic action can be tracked and recorded. This prevents the system from becoming a black box where nobody understands how decisions are made. With continuous monitoring and proper logging system, engineer and management team can easily identify error and improve system performance. In the long term, transparency increases trust in automation system, reduce downtime during inspection or audit, and support faster integration of new technology into global supply chain operation. Lastly, we have data integrity and cyber defense. RS2 robotic warehouse depend heavily on continuous communication and data sharing between robots, sensors, and control systems. Therefore, protecting this data is extremely important by applying strong cybersecurity practice and secure RS2 network. Company can prevent cyber attack, data manipulation, and system hijacking. In the long term, secure system help avoid major supply chain disruption and allow organizations to safely expand their robotic operation across multiple warehouse locations without exposing sensitive systems to the security threats. Thank you.